wasn't
What
very large.
causes a spinning disc, Mark?
What color was it?
What causes the spinning disc?
Well, based on the analysis by my electrical engineering friend who looked at the design of the ARV, it appeared that those cylinders that were underneath the disc on the ARV were actually a series of induction coils, and that those coils could be charged in sequence, and that would actually stimulate the rotation of the disc. I think that what Jeremy was saying about, or Jeremiah was saying about the disc being made of aluminum stands to reason, because I know that aluminum has.
Clarify it if you want.
So,
so here's the aluminum disc. This is a 6 1/4 inch diameter rotor data disc from the inside of a hard drive platter. And if we compare this and we take a look, so here's the inside of a induction motor, and for this case, for efficiency, they've slanted the non-magnetic metal shroud housing around this material with the laminated plates, and basically the magnetic field orbits, or it rotates and spins to induce a current flow because of the end caps here, an electric current flow through this rotor, and this would create the rotation. So if you do the same thing, basically, let's see. Do I have it sitting around?
This is wonderful. I love these demonstrations.
So if we take a coil assembly like this, now this coil assembly was designed to drive the internal diameter rotor, but if we were to take these coils facing inwards here and we were to flip them up so they were just sticking straight up like a bunch of solenoids next to each other, and we were to place them around the periphery near the closer to the edge, they would have more torque. But if we were to pulse them with a north and south interface here, between my fingers, for example, and then we were to suddenly shift the north-south interface to a position over here, the magnetic field of that shifting position from the north-south here to the north-south here would actually induce a current into and through the disk, causing the disk and the electrons within it to be dragged along, as the electrons wouldn't want to change their position within the magnetic flux being imparted on the disk. And
all right, so I could use the holes in there. I could use a hole in there, or put a turbine in there, put it in a cavity with the liquid mercury, and I could move that mercury around like crazy, right?
Oh yeah, you can move mercury around without any holes or gaps or anything else like that. All you need to do to move mercury around is place current flowing through it and place it within a magnetic field. Exactly. It's called magnetohydrodynamics. It's a whole entire study that you can research a lot.
No, never heard of it. Never heard of it.
I'm sorry, that was the basis of Faraday's original motor design, wasn't it? Was the mercury, the movement of mercury in a petri dish?
Yeah, I do believe so. With the it demonstrated the rotation of the magnetic field around in response.
Jump in. There may be many people who could explain this. What would the purpose of the rotation be in the ARV? What do you have any ideas why would you want the disk to rotate, I guess?
Well, I think the disk was functioning both as a stabilization device and probably as one of the elements of a homopolar generator. I don't know if Jeremiah agrees with that, but that certainly seems to be the case.
You mean like a flywheel? Like a flywheel?
Yeah, like a flywheel, yeah.
So this is really a big thing. It's not light. It's not.
No, in the case of the ARV, the 24-foot diameter disc, the 24-foot diameter ARV had a 9-foot diameter disc in the center of the disc. And I would have to imagine that they use some special techniques in the construction of that disc to make sure that it wouldn't come apart under high RPM. You know, maybe laminating a number of different layers of metal to construct it.
Now let me bring Ron Kita in, because I see that he there. Ron, you still with us?
I'm blank on the screen.
Yeah. Let me turn your camera back on here. Okay, ask start video, ask to unmute. There we go.
Am I there?
Yeah, there we go.
Start my video.
There we go.
Oh, I'm back.
Oh,
yeah, with homopolar. One thing we got into last time were the patents of Hank Wallace, who was a GE engineer out of Valley Forge Space Center, and he used metals that were higher than copper in which the number of electrons and protons must always equal. When you go to heavier metals up to plutonium, or beyond even, the heavier metals have an excess neutron. So Wallace claimed to get gravity shielding, you had to get a metal higher than copper, and bismuth qualifies, or mercury qualifies on the periodic table higher than copper. So when you spin them, you can orientate the neutrons within, the patents are 3.626.605, 3.626.606, and the best way to get to them is go to Rex. Are people familiar with Rex Research?
Yes.
No? Yeah. Now, Rex Research has a neat page for Wallace. You type that in, and on the opening screen, you'll see the New Scientist. The first section is New Scientist, February 14th, 1980. February 14th, 1970 was the day the patent was issued. And the New Scientist did a 10th anniversary article in the magazine. And the main thing, it mentions all about the Wallace and so forth. And the epilogue says the military was very upset that this patent came into public domain. The patent was not assigned to General Electric. It's in Wallace's own name, Henry W. Wallace. And as I mentioned before, he was fired for his gravity modification work. And he didn't envision, people kept telling him, stop your research. The people at GE are going to fire you. And he laughed because I went back and I looked at the patents of Henry Wallace, and he was quite accomplished. He, back in the 70s when the energy saving crisis was about, he did a lot of energy saving work. And I guess he made a lot of money for GE, and he was quite confident that his position with GE was secured. And then one day he had packed up his bag and he left. And he then went down to a scale company down in Shuberta, Mississippi, one of the, one of the scale companies. He worked there for a few years. Then he retired in Bradenton, Florida. He had a sailboat. He was well off. And then he died down there. And I guess he died down. We had a Thomas Townsend Brown. It was, I have to think of what car did I drive? Temple University Frontier Sciences under Nancy Calenda had a Thomas Townsend Brown symposium. They didn't have it at Temple. They had it at the Community College of Pennsylvania. And well, I won't get too far. I'm getting too far off the course here. Anyhow, when you get to metals that are heavier than copper, you get the extra neutron that can be mechanically spun polarized. I think with when you look at the patents, you'll see a brass wheel. And I don't know how many people are familiar with air-driven gyroscope wheels.
Yes, I've seen them.
Yeah, you've seen them. Okay. Well, in his patent, if you look at his patent, you'll see a brass alloy, which qualified. And what he would do is, from the patent, based upon the patent, he was using an air-driven aircraft style gyroscope. And his research, oddly enough, while he worked at GE Valley Forge Space Center, they moved everything down to, well, when I was in college, I interviewed at the Walnut Street facility of GE. It was they said it was an old bomb factory. It couldn't be a bomb factory in Center City. But anyhow.
Ron, are you talking about Walnut, Massachusetts?
Oh, no. This was Walnut Street, Philadelphia.
Oh, Walnut Street. Okay.
Yeah, Walnut, not Waltham. No, it's Walnut Street, Walnut Street, near 30th Street Station. And what happened is they gave him a basement lab down there. And what he had basically that gyroscope that he would air spin up, and then he'd undulate it. He'd just move it a few degrees off the axis center. And across the room on the other side, I think he used the gallium arsenide detector crystal. That's not familiar. People familiar with gallium arsenide detectors? Well, anyhow, he had the gallium arsenide mounted inside of a Faraday cage, which I guess which is probably aluminum screening of some kind. And whenever he would, I think it's probably in his patent, whenever he would undulate the high spinning brass rotor from the aircraft's gyroscope, the gallium arsenide detector would vibrate. And so he called that his kinematic field, because by virtue of this field going through a Faraday cage, that's largely the crux of his patent. And also, I think he does plots on temperature and so forth. We're almost dealing with the minutiae here. And so anyhow, nobody really gave him the go up to get into scale to make something meaningful out of it. And also, if you look at the patent, you'll see he had the aircraft gyroscope. There's a yoke, and I think the yoke it makes no sense, because anyhow, I think the yoke was made out of steel. You'll see this huge, massive yoke. It's probably 30 times the size of the small gyroscope. Why the yoke was there, I have no idea. But he called it a kinematic field because it was not electromagnetic, and it was changing the crystal across the room at probably 20 feet or so. And they also, someone said they stopped the subways from running as to prevent any vibration that may have caused the, but anyhow, you could tell whenever they moved the gyroscope, the gallium arsenide would, give out a signal.
Ron, let me put you back on mute. I have a couple more questions. If that's okay.
Yeah.
Let me go to Jacob Helvey, who has been patiently waiting, and then Wayne after that.
Yeah, okay.
I know Paul wants to say something too.
Hey, thanks, Tim. Hey, Mark. Really, the question I had here regarding the craft there. I'm just wondering how it actually, if there's any evidence or reports that you have of it actually interacting with the air or atmosphere. What sort of aerodynamic drag effects are reported, right? Like any sort of heating while it's pulling these high acceleration maneuvers. So if you comment on that a little bit, if at all.
Well, based on what I had been told in the film that was shown to the guests at this meeting, November 12th, 1988, at Norton Air Force Base. I'm sorry, at Lockheed Skunk Works up at Air Force Plant 42. There was no evidence of there being any kind of aerodynamic resistance at all. It was as though the system was not only demassing the vehicle, but a portion of the surrounding space-time, including the atmosphere. I've talked to eyewitnesses who've been dining at a restaurant on one of the bluffs in Laguna Beach, California, overlooking the ocean at night, and they've actually seen glowing objects accelerating and moving underneath the ocean offshore at tremendous velocities without any kind of wake being produced, without any kind of shock waves whatsoever, like the bow wake that you get off of a ship. These craft were apparently able to demass a portion of the surrounding water so that it basically be pushed aside without any inertia, without any interaction from, because of the mass of the water itself was being neutralized in such a way that the vehicle moving through the water and displacing the water was having no drag on the vehicle at all. The acceleration
would it be possible to be some sort of like a dampening effect? So maybe like
inertial dampening?
Or just there might be some turbulent effects there, but it would be like minimized to where, like, from our perception, it would seem like it's not affecting the air or the water.
Well, I know that, for example, when you see an aircraft moving through the air at high velocity, you see supersonic shock waves.
There's turbulent waves involved on the wingtips for sure.
Vortices and things like that. But from every account that I've been privy to, and from every event that I've personally witnessed, I have never seen any evidence of turbulence around the vehicle or in their wake. What I have seen, though, is ionization trails that follow behind them.
Okay.
When they move under a condition where the vehicle seems to be highly energized and is glowing brightly in the air. I couldn't tell you whether the glowing, the brightly was because the object itself was self-luminous or because it was putting such a tremendous charge on the surrounding air that the ionization was causing the production of stray photons that were producing the light that I saw. But I can tell you that when these things would move rapidly through the air under these energetic conditions, that they would leave a trail, a glowing trail of what appeared to be ionized air. So that's about the best I can do in terms of answering your question.
Okay, and then I guess there's no leftover, I don't know, effects or damaging of the hull itself, like scorch marks, maybe evidence of it entering the atmosphere or any of that sort.
Based on the description from the eyewitness, and I have more than one that have seen this thing up close enough to touch it, that there was no evidence of any kind of electrical scorching or any kind of ionizing damage done to the hull by the propulsion system.
Okay. And so, yeah, so before we go to Wayne, Mark, I want to ask, how are you doing on time? Oops.
Are we really looking at only a half hour left in our session?
Yeah.
It's amazing that it's gone this fast. It's hard to believe.
Well, I want to thank you so much. Thank you so much for joining us, and thank you so much for talking in depth. Actually, I've been worried because it's so in depth. I was like, I feel embarrassed. You know, I feel like we're just interrogating you.
Don't feel embarrassed. No. I welcome the questions. I mean, if I don't know the answer, I will tell you.
Well, it's exciting. And it's exciting to have you informed with people who are building things too, right? And then again, Mark, and and I mean, we've got 7 or 8 people here who are actively building things, and so so that's exciting.
It is. And I welcome. I would love to correspond with anyone who's actively participating in the construction of these devices, because I'm always interested to see what their outcome is with whatever they've come up with.
And actually, let me go to Mark really quick. He had a thing about bean spilling, and so Mark.
Yes, I was just wanted to say to Ron Kita that we really love you and you're helping out a lot, but we want you to keep topic to what we're talking about now, and you need like a 4-hour session, maybe even a 5-hour session to just spill everything in one shot, and don't spill all the beans now, because we want something to be excited about for next week. Okay.
Yeah.
And Ron is actually driving distance from us. I hope to get you down to the lab when everyone's together and running experiments.
Ron, you're muted.
Is he?
Sorry. Yeah, Ron, you're muted. Unmute. We can't hear you.
2. Okay, you're gonna have to.
Okay. Well,
I just want to add. I'll make a quick interjection. I built a hell of a lot of stuff. I built a Mercury gyroscope.
Definitely want you in the lab.
Well, anyhow, I just want to make a comment. When you build a gyroscope, I took a zinc die-cast pulley. I put an insulator or tape around the steel die-cast pulley, wrapped a strap around the outside. What I found out, you have to drive electric current right under a magnet to get it to work. If you don't drive it, this is a short thing. If you don't drive the electric current under a high-powered magnetic field, you won't get the spin. It does work. Easy to build. That's it.
Okay. Ron, we'll have you in the lab, and we'll work on that together. But questions for Mark McCandlish?
Well, and so we have Wayne, actually. We do have Wayne.
Yes, go ahead, Wayne.
Yeah, hi. So I just wanted to touch on that rotating metal. So I was just thinking about that, and I just want to submit that I don't believe it was Mercury, but I think maybe something that seems more probable would be cesium. And the reason for that is cesium is a liquid at 28 degrees Celsius, and it also has 100% in abundance a spin. Let me look it up here. The nuclear spin is I think it was 7/2. I don't know. I could be wrong, but it was up there. So it has a and it's also heavy too. Atomic number 55, I think it was. I was looking at it a few minutes ago. So it's a heavy liquid metal, and it has, the high nuclear spin. In contrast to Mercury, which does have like its isotope is
just below uranium, isn't it?
13%.
Atomic table.
Mercury is a little hard to see here. Just give me a moment.
It's like 199 or something. Isn't it?
Mercury 199 has a 1/2 nuclear spin, but it's only about 17% in abundance. So most of the Mercury is spin neutral, which means just mass, right? So by spinning it rapidly, the nuclei are not going to polarize. So if that is the mechanism in which this mass cancellation effect happens, where the nuclei are polarizing or aligning on one axis or plane, then I don't think Mercury would be a very good candidate. So
interesting. Yeah.
Yeah.
Great observation. Say, listen, just let me interject before we run out of time that I would love to correspond with any and all of the people that are in on this conference here. That includes you, Wayne, and Ron especially, and David. Oh, David Mathis. Hi.
How you doing?
Yeah. Nice to see you.
Mark, if you want to converse with us in real time as we're doing the experiments, you would need to download the WhatsApp app on your phone and give me your phone number and we can add you. We have a chat group that literally goes 24/7 of actual engineerable ideas. And we try to keep it to just that topic, engineering ideas that are happening right now, a soldering problem, something you're working on, all different problems we're sharing worldwide. And that's the place you want to be. So make sure to get the WhatsApp app on your phone if you don't already have it.
Yeah,
Okay.
and then I think also, Mark, I believe everyone on this list has your email, but if you want to give that out, although,
yeah.
We are, and in fact, I should mention this now. So we're looking at putting this up online. Is everyone here okay with that?
Sure. Yeah, I am.
Okay.
I am. Yeah. I haven't named any names in terms of the abductees, and yeah, I try to be real careful about that these days. But I have no problem putting up my.
I think what's really important about the abductee cases is whether we can trust her and whether what she saw about the engineerable side of the craft is valid, and if there's any theory that we can attribute it to and try out in the lab and order that equipment. That's like the focus of APEC conference.
Well, let me just interject.
Engineering underlined.
Let me just interject, Mark, that one of the reasons that I found that particular case so compelling was the fact that in order to sort of prevent any cross-pollination information-wise between what I had to say about the structure of the ARV, how it was put together, how it worked, and so forth, I didn't share any of that information publicly prior to this young lady describing the components in the craft that she saw. I had never been on the air or talked publicly to anyone on a radio program or anything about the ARV when I heard from within the UFO community that there had been this group of abductees, and this was one of the first people that I talked to before I ever went public. So she was describing components that had a lot of commonality with the things that I had seen in the ARV, but she had no idea what I had to say. She was basically just talking in the blind about her experience, and I was seeing, a common thread between the components that I was familiar with from the ARV and the things that she was describing from the craft that she had been taken up in.